Welcome to this video on statistics, presented by Darren Lefko. Statistics is the collection, presentation, analysis, and interpretation of numerical data. It's both a science and an art for handling figures and facts. We'll explore two main types: descriptive statistics, which involves collecting, summarizing, and describing data, and inferential statistics, which focuses on drawing conclusions or making decisions about a population based on sample data. In statistics, a population is the entire group you wish to draw conclusions about. A sample, on the other hand, is the specific subgroup from which you collect data. Let's look at the levels of measurement. Ratio measures numerical values where the relationship between quantities is significant. Interval also measures numerical values, but here, the difference between values is meaningful, with order present. Ordinal involves ranking ordered categories, indicating the order or rank of items. Finally, nominal refers to categorical codes, ID numbers, or category names, simply identifying something. Measures of central tendency represent the center point of a dataset, indicating where most values fall. The three most common measures are the mean, median, and mode, each calculating the central point differently. The mean is the arithmetic average. To calculate it, you sum all values and divide by the number of observations in your dataset. The median is the middle value, splitting the dataset in half. You find it by ordering your data from smallest to largest, and then locating the data point with an equal number of values above and below it. The mode is the value that appears most frequently in your dataset. A measure of variability is a summary statistic that shows the dispersion in a dataset. It defines how far data points tend to be from the center. Low dispersion means data points are clustered, while high dispersion means they are spread out. This visual illustrates how variability can differ, even when the mean is the same. A narrower curve indicates lower variability, while a broader curve shows higher variability. Variance is the average squared difference of values from the mean. It includes all values by comparing each to the mean. You calculate it by summing the squared differences between data points and the mean, then dividing by the number of observations. The formula for population variance uses sigma squared as the population parameter for variance, micro as the parameter for the population mean, and n as the number of data points. For sample variance, GOAT squared is the sample variance, and m is the sample mean. The n1 in the denominator corrects for the tendency of a sample to underestimate the population variance. Standard deviation is simply the square root of the variance. It represents the typical difference between each data point and the mean. A smaller standard deviation indicates data points are grouped closer, while a larger one means they are more spread out. This slide displays the formulas for both sample and population standard deviation. Note that for large values of n, the sample and population standard deviations become quite similar. Sampling is a technique for selecting a predetermined number of samples from a larger population with similar characteristics. It's used when gathering information from everyone is impractical due to resource or time constraints, allowing us to draw conclusions about populations from samples. Sampling techniques are broadly categorized into two types: probabilistic sampling and non-probabilistic sampling. Each category includes several distinct methods, as shown in the diagram. Here are examples of probabilistic sampling methods: simple random sampling, stratified sampling, cluster sampling, and systematic sampling. Non-probabilistic sampling includes methods like snowball sampling, where new participants are referred by existing ones. Convenient sampling selects easily accessible participants. Judgmental sampling relies on the researcher's expertise, and quota sampling involves selecting units until a predetermined number or proportion is met within subgroups. The two main sampling techniques are probability and non-probability sampling. Probability sampling involves random participant selection, ensuring each has a chance of being chosen. Non-probability sampling is ideal for qualitative and exploratory investigations, as it does not rely on random selection. In probabilistic sampling, stratified sampling is used when a population has mixed characteristics, ensuring equal representation of each. Simple random sampling provides every individual in the population an equal chance of being selected as a participant. Systematic sampling is a probability method where individuals are chosen at regular intervals from a complete list. Cluster sampling involves categorizing the population into subgroups, ensuring each group has similar characteristics. In non-probabilistic sampling, snowball sampling relies on existing subjects to refer new participants. Convenient sampling involves collecting data from readily available respondents. Judgmental sampling, also known as authoritative sampling, involves a researcher selecting units based on their existing knowledge or professional judgment. Quota sampling is a non-probability technique where researchers form a sample representative of a larger population. Oversampling involves duplicating samples from the minority class. Random oversampling selects random examples with replacement, adding multiple copies to the training data, meaning a single instance might be selected multiple times. Undersampling means deleting samples from the majority class to reduce bias in imbalanced datasets. This can be combined with oversampling the minority class, but undersampling is generally more effective for large datasets. A probability distribution describes how probabilities are distributed over the values of a random variable. It can be discrete, with examples like binomial, Poisson, geometric, and uniform distributions, or continuous, including normal, exponential, and logistic distributions. The normal distribution, also known as the Gaussian distribution, is a continuous probability distribution that is symmetric around the mean. Data near the mean are more frequent, forming a bell curve. This concept was developed by Carl Friedrich Gauss in the early 19th century. The binomial distribution is a discrete probability distribution. It models the number of successes in a sequence of independent experiments, each with a binary outcome, success or failure. The formula for its probability is also shown. The Poisson distribution is a discrete probability distribution that shows how many times an event is likely to occur within a specified period. It's useful for understanding independent events happening at a constant rate over time. Bayes' theorem provides a method to calculate conditional probability. It states that the conditional probability of an event X given event Y equals the product of the likelihood of Y given X and the probability of X. Bayes' theorem, named after Thomas Bayes, is a formula used for conditional probability. Its formal definition helps calculate the probability of an event based on prior knowledge of conditions that might be related to the event. The central limit theorem, or CLT, states that as the sample size increases, the distribution of sample means approximates a normal distribution. Generally, sample sizes of 30 or more are considered sufficient for the CLT to hold. The central limit theorem is applicable for sufficiently large sample sizes, typically n greater than or equal to 30. The formula for the central limit theorem helps to describe this approximation.